I think it's possible to create a much better airplane. That I have a design in mind for a vertical takeoff and landing supersonic electric jet. It kind of combines what I've learned at SpaceX and Tesla, because sort of SpaceX has got the aerospace side of things and Tesla's got the electric powertrain side. And I think that would be a really cool vehicle to have in the world, because you wouldn't need big runways, and you could get places fast, and be relatively quiet, and of course it would be very low cost to operate, and good for the environment and all that.
Well, I mean, the exciting thing to do would be some sort of electric vertical takeoff and landing supersonic jet of some kind.
Vertical takeoff and landing meaning no need for a runway. Just shoot up straight in the air and then...
Yes. The trick is that you have to transition to level flight, and then the thing that you would use for vertical takeoff and landing is not suitable for high-speed flight. The interesting thing about an electric plane is that you want to go as high as possible, but you need a certain energy density in the battery pack, because you have to overcome gravitational potential energy. Once you've overcome gravitational potential energy and you're at a high altitude, the energy you use in cruise is very low, and then you can recapture a large part of the gravitational potential energy on the way down. So you really don't need any kind of reserve fuel, if you will, because you have the energy of height, gravitational potential energy. This is a lot of energy. So once you can get high, the way to think about a plane is it's a force balance. So the force balance. So a plane that is not accelerating is a neutral force balance. You have the force of gravity, you have the lift force of the wings, then you've got the force of the whatever thrusting device, the propeller or turbine or whatever it is, and you've got the resistance force of the air. Now, the higher you go, the lower the air resistance is. Air density drops exponentially, but drag increases with the square. An exponential beats a square. The higher you go, the faster you will go for the same amount of energy. And at a certain altitude, you can go supersonic with less energy per mile, quite a lot less energy per mile than an aircraft at 35,000 feet, because it's just a force balance.
And do you have specific plans?
I've been sort of toying with the design for an electric supersonic vertical takeoff and landing electric aircraft for a while. I'd love to do it, but I think my mind would explode. It's like pretty saturated working on electric cars and rockets.
I think the optimal sort of air transport solution is a VTOL electric supersonic plane, and it actually works together quite well for a bunch of reasons. In particular, the higher you go, the better the more efficient the electric aircraft is. Whereas if you have a combustion aircraft, as you get higher, it tends to get worse because you have a kind of a fixed aperture and
air scoop.
Yeah, like the engine is the hole in the front of the engine is a fixed size, and so you have to pick a particular cruising altitude, and so you've got to figure out how do you get the right amount of air at sea level all the way through really high altitude. And then you've got this issue of supersonic combustion that, so you end up having to slow the air down, and it ends up being not that efficient. But an electric aircraft would just get better and better as it got higher. And then electric motors have a higher power to weight ratio than a combustion engine. So you could actually have the power to do the vertical takeoff and landing part with a fairly small motor compared to combustion. And then you could get rid of the elevator and rudder, so you don't need the rear control surfaces if you gimbal the motor. But the real trick of it is how do you make it really long range and at least as safe as existing aircraft? But those are really the only two questions on that front, I think.
And battery energy density is improving every year, so that's an important metric to get the cell energy density to
around 450, 500 watt-hours per kilogram, and have a pack efficiency of around 400 watt-hours per kilogram. That's when electric planes start to get interesting. So in my opinion at least, for real cells that actually work and don't have like some huge drawback, they're currently at about 300 watt-hours per kilogram. And if to have a compelling aircraft, you only really need about 400 watt-hours per kilogram, provided the percentage of cell on the aircraft is high. It doesn't need to be anywhere near as high as it is on a rocket. But if it's sort of at the 70% level, at 400 watt-hours per kilogram, you can do very decent range. And if you sort of move it up to the sort of mid to high 70s, you can go transcontinental, but not intercontinental, but sort of west coast to east coast. So you need an efficient aircraft, but that's approximately, by my calculations, the numbers you need: 400 watt-hours per kilogram, mid to high 70s cell mass fraction, which I think is an achievable number. Because like aircraft have all these like unnecessary things like tails and like rudders and elevators, like not needed. Just gimbal, gimbal the electric fan. Like for some weird reason, like gimbaling motors is normal in rockets and not in aircraft. Well, why not? But electric planes, I've been dying to do that for a decade, honestly. But we got quite a few fish to fry here. So maybe one day the electric plane.
Man, building an electric airplane has a lot of difficulty associated with that. It takes a massive amount of effort to do any one of these things, so you can't do them all. It's not possible. Say, how you allocate the resources? What's the best thing to do? Making a VTOL jet can definitely be done. Doing electric aircraft for sure. I mean, all transport will go electric except for rockets. I think it's incredibly hard to bring an aircraft to production and meet all of the regulatory requirements worldwide. It's a very difficult thing. So it's not like it's something that could just be done. We would have to not do a bunch of other things. It's not like there's like a ton of unallocated resources that tells them like, oh, what should we do now? It's like a constant resource starvation.
I don't know, it'd be a fun problem to work on at some point. But we got a lot to do over the next few years, so we're going to focus on these things, get them right, and maybe one day do that.